Hi everyone, my name is Mr. Porchot, and today I'm going to talk to you about Pythagorean theorem. So I'll go ahead and write that for you right now. So the first question is, what is Pythagorean? And the second question is, what is a theorem? So Pythagorean simply refers to the ancient Greek philosopher Pythagoras, who lived in the 500s BC. He was an interesting fellow. He loved math so much that he created a school, which later became a religious organization dedicated to the fundamental aspects of math. Big question is, did Pythagoras invent this theorem? We're actually not sure. It could have been one of his students, and because of Pythagoras' prominence, was later attributed to him, or it could have been a theorem that Pythagoras stumbled across while traveling in the Middle East. Either way, Pythagorean theorem is attributed to Pythagoras, and if you are very interested in history and you love your history class, that could be a question for you to study on your own. Now, the second question we might be asking ourselves is, what is a theorem? Now, a theorem is actually a statement that can be proven with mathematics, and we usually use variables to do that. As per Pythagorean theorem is used to determine the distance of the sides of a right triangle. So let's draw us up a right triangle right now. Here is a right triangle. I'll probably make a little bit of a flatter side there. And if you notice, I actually drew a little box right here in that corner. And what that box indicates is this corner is a 90-degree angle. And this is important because we cannot apply Pythagorean theorem to a triangle that is not a right triangle. So it must be a right triangle. Very important. This will not work unless we are doing a right triangle. So there are actually different sides of a right triangle, and we'll talk about that right now. So this is called a leg. This is also called a leg, and this is called a hypotenuse. Well, I know what you're thinking. You're thinking, well, Mr. Porchot, how do we know what is a leg and what is a hypotenuse? It's a very easy explanation to that. You see, you'll notice that the legs are connected to the corner with that right triangle. The legs are connected to that right angle, just like our legs are connected to our hip bones. So just like our legs are connected to our hip bones, the two legs of a right triangle are connected to that corner with that 90-degree angle. The hypotenuse is always across from that angle. So if you see that longer end that is across from that right angle, you're looking at a hypotenuse. So now we're going to actually talk about the theorem itself. We're going to talk about the statement that is attributed to Pythagoras. And that statement is a squared plus b squared equals c squared. So let's go ahead and plug in those values. So we usually consider a leg to be either an A or a B. And we can use these interchangeably. We can use this one as B and this one as A, as long as we are consistent throughout the equation and throughout our algebra. But we'll just go ahead and keep it consistent in alphabetical order, right to left, left to right. Left to right. So A and then B, and then our C is always going to be our hypotenuse. And C needs to be consistently C, and always has to be our hypotenuse when we're looking at these right triangles. So let's say they give us the values of A and B. So let's say we have an A, and let's say that A is 3 inches. And we have a B of 4 inches. What we're going to do is we're going to use Pythagorean theorem to determine the value of our C variable. So A squared is going to be our 3 squared. B squared is going to be our 4 squared. And of course, we're still looking for that C squared, so we'll just rewrite that C squared variable. We know our powers. We know how to square a number. So 3 squared, in other words, 3 times 3 is 9. 4 times 4, or 4 squared, is 16 equals c squared. What we're going to do is we're going to go ahead and add these values to 25. It's going to bring us to c squared. And the way we solve this, the way we solve the very, very, very end, is we want to get rid of that pesky squared, so we're going to do the opposite, which is square root. So the square root of c squared, the square root of 25, is going to give us a value of c. I'll write it right here. C equals 5. So we can get rid of this c and just write 5 inches. And this is a very common triangle we see. It's called a 3, 4, 5 triangle. So let's try it with a little bit more unusual numbers. You know, I'm just going to go ahead and erase everything and draw a new triangle, because that's a beat up triangle if you ask me. We have our new triangle. And then again, we're going to have our 90-degree box right here. And let's do the value. Let's go ahead and keep the 3, but let's do a 2 right here, okay? We're still looking for our hypotenuse. So a squared plus b squared equals c squared. We're going to go ahead and plug in our 2 squared. And remember, you can do these in whatever order you like, as long as the c is at the other end of that equal sign there. So 2 squared plus 3 squared equals c squared. Okay, I love it. I love it. So 4 plus 9 equals c squared. In other words, 13 equals c squared. What we're going to do is take that square root again, and we're going to be left with an irrational number, and that is the square root of 13. Now, if you love math, you love getting down to those very, very small units, then you could actually do that on a calculator and get the value. I don't remember what it is on the top of my head, but you can actually find that specific irrational number, which will be a decimal. But for right now, for this lesson, we're actually totally good to just keep our value as 13. And we can even put that right there as 13, and we are good to go. But I know what you're thinking. You're thinking, hey, Mr. Porchot, that's all fine and good. But what if we have the value of our hypotenuse, but we need to find the value of one of our legs? No problem. The theorem still works out, and the theorem still checks out. So let's say we have a hypotenuse. Our c is 10. Maybe we have 8 right here, and we still don't know the value of this side. That is our missing variable. We do not panic. Do not panic. We can still use Pythagorean Theorem, and everything is going to work out just fine. So bear with me. A squared plus b squared equals c squared. No surprises there. We're going to go ahead and keep our a squared consistent because we don't know that value. Plus 8 squared equals 10. There's the c, there's that b, and we're still looking for a. 64, because 8 times 8 is 64, we're looking for that square, equals 100. And what we're going to do this time is we're actually going to isolate that variable, which is what we do in algebra. So we'll do some algebra really quick. Minus that 64 over, we're going to end up with a squared equals 36. Square root that bad boy, just like we did before. A equals 6. So we're going to go ahead and erase that a, write that number 6, and we finally solved all of those distances for this triangle. And there you have it. There is Pythagorean Theorem. I hope you enjoyed this video. But before we end things, before we let you guys go, we just want to talk about why this is important, why this is helpful, and why this is useful in everyday life. Because that's the big question. Why are we learning this? How does this apply to the problems that we face in the real world? Very, very simple solution to that. When we are in the real world, we are tasked with difficult problems. We face challenging times, and we might not know what to do. But when we do face those challenges, when we do have a variable, when we have a variable like a, they'll always give us our C, they'll always give us our B. So we have things to help us. We have information that we can evaluate and assess. We can do these steps, not these particular steps in every time, but we can always find other steps to find the solutions in life. So I hope you found that meaningful. I know I did. Have a sensational day. Continue practicing the Pythagorean Theorem, and we'll see you next time.